Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is ways to express an integer as sum of powers. Now the problem category is of medium level, but I would say it's a very easy problem to solve. After watching this video, after understanding the problem and the solution approach, you are also going to find it easy. In the problem, we are given input and we are given two positive integers n and x. So this is our input. The output we need to give in the problem is we need to return the number of ways we can express, or n can be expressed as this particular formula. So we are given a formula which involves x, and what we need to do is we need to make sure that this formula is equal to n. That is, we need to return the number of ways this value n can be expressed as this formula. The formula is you have to choose some numbers n1 to the power x plus n2 to the power x up to nk to the power x should be equal to n. Basically, you have to choose some numbers n1, n2, n3, n4 up to nk. This k is not given in the problem. You have to decide it. Basically, we need to find the number of ways, right? So we can decide a lot of different ways. That is, we want to make sure that if we decide few numbers n1, n2, n3 up to nk, and we raise all the numbers to the power of x, that is n1 to the power of x, n2 to the power of x up to nk to the power of x, take the sum of all of these, it should be equal to n. You have to make sure that this n1, n2, n3, nk all are unique in a particular set or in a particular way. Now, if you are confused with the problem, no worries. Let's try to understand it with the example where the given value of n is 100 and x is equal to 2. What we need to find out is we need to return the number of ways this n can be expressed as this formula, right? The formula is choose some numbers, raise them to the power of x. This x is given in the input, and take the sum. The sum should be equal to n. In how many ways can you do it? Also, you have to ensure that in a particular way, this n1, n2, n3 all should be unique, and no numbers should be repeated in a particular way. For example, if I talk about this particular input, there are three ways to express the number 100 using this particular formula. Those three ways are here. What we can basically say is 100 is equal to 8 square plus 6 square. Why are we taking the square? Because x is equal to 2. If x would have been 3, x would have been 4, we would have tried to express the number 100 in the form of 8 to the power 4 or 8 to the power 3 plus 6 to the power 3. Here x is equal to 2, so we want to express our number 100 or whatever n is given in this particular way, where the numbers are 8 and 6. 8 is to power 6 plus 6 is to power 6 is equal to 100. This is equal to 64, this is equal to 36, their sum is equal to 100. Also, what we can do is we can say 100 can also be expressed as 10 square. Whatever number we choose, 10, 8 or 6, we have to just take the square of this because x is 2. 10 square is also equal to 100. So we got two ways. One is 8 and 6, raise them to the power of 2, take the sum, it will be 100, right? Or I can say take just one number 10 and take the square, this will be 100, right? There is one more way, which is 7 square plus 5 square plus 4 square plus 3 square plus 1 square. You will notice that we have chose 5 numbers, 7, 5, 4, 3 and 1. None of them are repeated, all are unique, right? We have to ensure all should be unique. You don't have to use a particular number more than once. So this formula will be 49 plus 25 plus 16 plus 9 plus 1, which is equal to 100. This is equal to 74, then 90, 99 plus 1, which is 100. So these are the three ways. So the output for this particular input will be 3. Now how can we solve this? The thing is, you will first need to understand some maths about the problem, and then you will have to understand the pattern, and then you will yourself be able to find out the way to solve the problem. Now let me show you some maths for this particular problem. Now let us say we are given the input n is equal to 100 and the value of x is equal to 2. Now if you remember, the formula which we have is we have to express this number 100 in a form of n1 square or n1 to the power of x plus n2 to the power of x up to nk to the power of x. You can choose k numbers, raise all of them to the power of x, the sum should be equal to 100. So the first observation we have is we cannot have a number in our formula whose power of x, let us say we have a number k, whose power of x cannot be more than 100, right? If it is more than 100, then your sum will never be less than or equal to 100. So we first need to identify, and now this is the first way to solve the problem. We first need to identify what's the highest number k such that k to the power of x is either less than or equal to 100. For example, if the value of n is 100, right? I cannot create a formula, I cannot create a way in which I can say 11 is to power 2 plus some more numbers whose power of 2 is equal to 100. Because this alone will be equal to 121, right? If you have 121 and you keep adding some numbers, you will never get 100, right? So I had to find the upper limit. At least I should have that upper limit with me, and that upper limit is the highest number k such that k is to power x will be less than or equal to 100. How can you calculate this? You can say take the power of both the sides as 1 by x. Now I am just doing some basic mathematics. If you take the power of 1 by x in both the sides, basically in the left hand side, this x and the 1 by x will cancel each other, right? So this will be equal to k, and this side will become 100 is to power 1 by x, or I can say n is to power 1 by x, right? Now let us try to calculate the value of k for few values. Let us say we have to find the value of k for 100. So I can say k will be less than equal to 100 to the power 1 by 2 because this 2 is equal to x. I mean x is equal to 2, right? If this x would have been 4, this would have been 1 by 4. So we basically want to find out the value of k which should be less than or equal to 100 to the power 1 by 2. This will basically be equal to 10. You can calculate this in Python in this way. You can say 100 to the power 1 by 2, right? This will be equal to 10. Basically we want to find out the power of one number raised to another number. So k will be less than equal to 10, right? So k can be equal to 10. So I can say 10 square or 10 is to power x will be equal to 100 or will be less than 100 and it will never be more than 100. So from here what I can understand is I have to create a formula in which my numbers will never be more than 10. If I have a number more than 10, then that number raised to the power of x will be more than 100 itself, right? So I know my upper limit now. What about if the value of n is equal to 90? In this case, you will have k less than equal to 90 to power 1 by 2. This will be approximately equal to 9.5. So k will be less than equal to 9.5. So in this case, you will take the value of k is equal to 9 and not 10. Because if you take the value of k as the upper limit of 9.5, which is 10, then it will be 10 square, which is 100, more than our n. But if you take the lower number, that is, you take the lower bound of this, it will be 9. 9 square will be 81, right? So now if you have 81, you will have to search for 9 more to make 81 plus 9 equal to 90. So we have to take the lower limit because our numbers in our formula will be integers. Now let us try to solve the problem in the first way, where we know the upper limit. If you know the upper limit, that is if the value of n is equal to 100 and the value of x is equal to 2, let me write it, x is equal to 2, then in this case, what you have to do is you have to find the value of k, right? First of all, k is equal to 10. That is, in your formula, you cannot have values more than 10, but you can have values less than 10, right? For 100, we have three answers. We have 8 and 6, right? 8 square plus 6 square is 100. We have one more answer, which is 10 square is 100. We have 7, 5, 4, 3 and 1. Their squares, taking the sum, will be equal to 100. We have to find all three answers, but all the three answers have numbers which are less than equal to k, which is 10. This is something we are going to calculate first. Now, this problem completely tells me about dynamic programming. And how can you understand this is dynamic programming? See, if you have 100 originally and you know the upper bound, right? But you don't know the answer, right? I don't know if this 10 will be involved in one of the way, in one of the formula. But I know that whatever is my formula, the numbers in that formula will never be more than 10. So what I can do is I can say either I may have 10 in one of the ways or I may not have 10 in any ways, right? Both can happen. So I can say if I have 10 in one of the ways, in one of the answers, then let me include 10. If I include 10, then it will be 10 square because 10 is to power x, which will be 100, right? I need 100, right? And I got 100 if I choose 10 in one of the ways. I need 100, I got 100. How much more I need? I need 0 more. If I need 0 more, then I know that this is one of the way. So I got my first way in which I have to choose just one number, which is 10. But what more I can do is I can say let's not include 10 in my answer. If I don't include 10, then let me go one step down. Let me start with 9, right? It means my highest number now in my formula will be 9. I already have got one answer, but now let me try to get more answers in which 9 is going to be the upper bound. I have to find 100, total of 100. Again, I have two choices. Either I can include 9 in my answer in my number of ways, or I may exclude 9 in my number of ways. I will choose both, right? I can say 9 square is 81. I need 100, I got 81, so I need 19 more. So with 19, I will again start searching for any ways or the number of ways. But now when I start searching with 19, I may not choose any number which is more than 9. So I will have to start with 8 because I started with 9 and I reached to this particular point. So you will see that we are building sub problems from a particular problem. We have a problem where we want to find out for 100 and we have to start with 10. That is 10 can be our highest power. This is something we calculated. So now we are building sub problems. We are saying that, okay, if you are taking 10, then it will be 10 square 100. It is used, fine. But if you don't take 10, then we have 9. Again, two options. Either I take the 9, 9 square is 81, 19 is left. So now I have to calculate that how many ways I can create the sum as 19 such that my highest power I have to use or the highest integer I have to use in my formula is 8. I will not include 9 because I have already included 9, right? Or what I can do is at this point 9, I can again try to ignore the 9. Let's ignore 9 and let's start with 8. That is, I have to search for 100, but the highest power to start with is 8. If you include 8, it will be 64. Then you will be left with 36. Or what you can do is you can exclude 8. You can skip 8 and now you have to find 100, power of a total of 100, but the highest power can be 7. Any moment when you found the number which is equal to your finding number, then you can say that you found a way. For example, at this point we try to find 100. We got 10. 10 square is 100. We try to find 100. We got 100. It means it is good. It is the perfect way. So now we don't need to search further. But with these options, we have to search, right? So this is completely dynamic programming. We are having a problem. We are building sub problems and we are trying to calculate our answer for the problem using sub problems. This is one of the way to solve it, where you will have to calculate the value of k. Now let me tell you a simple way in which you don't even want to calculate the value of k. In this way, what we are going to do is we are going to say, let us start with the lowest number. Let's start with 1. That is, if I have to find the number of ways to achieve the sum equal to 100 in my formula, then let me start with 1. Again, I have two options. I will choose 1 in my formula, or I will not choose 1 in my formula. That is, I can say, let's choose 1. 1 square will be equal to 1. So now I have to find 99 more because I started with 100. I have to find 99 more. I have utilized the value of 1. Now I will start with 2. Or I can say, I will not make use of 1. Let us try to find out 100, but starting with 2. So again, I'm creating sub problems. I started with an initial problem where I have to calculate the value of 100 starting with 1. That is, this is the sum I want to create. This is my initial number in my formula. You know the formula, right? We have n1 to the power of x, n2 to the power of x, up to nk to the power of x. I am saying that my minimum number will be 1. Earlier, I was trying to find out my maximum. Now, I don't need to calculate. What I will do is, I will start with my minimum number and I will keep increasing my number. I will say, okay, I will start with 1 square, then I will be having 2 square, then I will be having 3 squares, but my sum is going to decrease. At any point when I will get a number k whose power of x is equal to the number I need, I will get one way, right? But if at any point I am at a number k such that the power of x is more than what I need, then in this case I will have to stop, because now I am getting the powers which are more than I need. Now my sum will be more than 100. For example, I can start with 100, my number will be 1, and I have the x is equal to 2. So I can say either I can include this 1, so it will be 1 square because we have x equal to 2. So either we can include the 1 or we will skip the 1. If you include, you need 99 more, the next number will be 2. If you exclude or skip, you will need 100 more, but you will have to start with 2 now. Again, for each number, I have two options. Either include, if you include the 2 square, then you will need 96 more and you will have to start with 3. If you don't include, then you will have 100 needed and you will have to start with 3. In this particular case, you will start with 95 if you include 2, or if you skip 2, then you will have to start with 99, so trying to search for a sum of 99 starting with 3. This way you can calculate and find the number of ways. Now it is very hard to demonstrate for 100, so let me try to do it for 10. If you want to find out the answer for 10 and the value of x is equal to 2, and you start with the lowest number 1, so if you include 1, you will have 9 left. If you skip 1, you will have 10 left. But now you will start with 2. That is, you will take the 2 power 2. This 2 is equal to x. Again, if you start with 2, you have two options with both the numbers. If I choose 2, I will need 5 more. If I skip 2, I will need 9 more. For 10, if I choose 2, I will need 6 more. If I skip 2, I will need 10 more, because I am removing 2's to power 2. That is, this is my number nk, and this is x. Now my nk will be 3. That is, now I will have to add 3 to power x. So if you remove 3 to power x from 5, this will be negative. So we can stop, because if it is negative, it means that now you are trying to add numbers and your sum is more than 10. So you can stop. But for this one, you will see that 3 square is equal to 9. This is what you needed. This is 0. So you got away. Again, for this one, it will be negative because 3 square is 9. You just need 6. So it is negative. Stop. But what about this one? You can say that if you include the 3 square, it will need 1 more. If you don't include 3 square, it will still need 10 more. Next time you will start with 4. 4 square is 16, which is more than 1, more than 10. So both will become negative and you can stop. So you just got one way, right? This was your way, and the output will be 1 when n is equal to 10 and x is equal to 2. This is how we can solve the problem, and I have gone in depth to explain you the problem, even though it is easy to understand. I want everyone to understand this, because this is one of the most classical things you will have to understand whenever you try to solve a dynamic programming problem. Now let me take you back to the code editor and let's solve the problem. First of all, I have taken the mod which is equal to 10 to the power 9 plus 7, because the question says that the answer or the result can be very large, so return it to the modulo of 10 to the power 9 plus 7. Now I have defined a DP function where we are going to perform our logic, and what I'm trying to return is I'm calling the DP function with the given value of n and my starting point 1. I am saying in my formula my first number will be 1 and n is the sum I need. Now in my DP function I have two variables, remaining and current. First of all, I'm creating a tuple of these values because at some point I might want to calculate the same value of remaining and current. That is, the DP function will be called with the same value of remaining and the same value of current multiple times. For bigger numbers, this recursion tree can have same requirements. So we are not going to solve the same sub problem. We are going to store it in a data, and that's what we have here, a data dictionary. So we have a tuple which is remaining comma current, our input, and then if this tuple is already in the data, we can directly return its value. But initially we are not going to have it. So what we can say is, let's say the power will be current to the power of x. Basically, current is our initial number, which we are going to increase later on, and we have to raise our numbers to the power of x, right? That's our formula. So power is equal to current to the power of x. If the remaining is equal to 0, that is, if what you need is already 0, so you can return 1. That is, you got one way in which this formula is valid. The power, this particular value is more than remaining, means now you don't need to calculate any further. You will never get away with this particular current value. Reason being, current to the power of x is more than remaining. Or next, what you can do is, you have two options. Either you can take this power in your remaining, or you can skip this. So let's try both. You can say take is equal to DP function, call the DP function again with the remaining sum, remaining minus power, and current will be current plus 1. If you skip this, then you can say skip is equal to DP function call with the remaining value, the initial remaining value, comma current plus 1. After you calculate both of these, you can store it in your data. You can say data of the tuple is equal to take plus skip mod and then you can finally return the value of data of tuple, which is basically this particular value. After you are done, you will get your answer and you can submit this, and this is going to pass all your test cases. You can see the runtime is good, the memory used is good as well. We can improve this, but I think it's a very optimal solution for this particular problem. So we have solved this particular problem in a very optimal way. So that's it for this video, guys. If this video has explained you the problem, the solution approach, and everything in depth, then make sure that you are hitting that like button. And if you're not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. I want to see you guys in the next video. Thank you for watching this one.